Okay, layers of the atmosphere. Now, in our atmosphere, there are layers of it, just as if there were layers on the inside of our Earth, like we talked about. In this case, the scientists divide the Earth's atmosphere into 4 main layers, and they're classified according to their changes in temperature. The layers are the troposphere, the stratosphere, the mesosphere, and the thermosphere. And we're going to talk about those in more detail. The first of the 4 layers is the troposphere. This is the smallest of all the layers. It is an average of about 12 kilometers thick. However, it can be as much as 16 kilometers down towards the equator and as little as 9 kilometers thick up towards either of the North or the South Pole. Now, however, even though this is the smallest of all the layers, it is actually the most dense of all the layers too. It has the most molecules of air and has the most mass in our atmosphere. It actually contains almost all of the mass of the atmosphere. Now, the temperature changes also within this as the farther you go up in the atmosphere, the farther you go up in the troposphere, it actually gets colder and colder and colder until it gets to approximately negative 60 degrees Celsius where it stops. It no longer gets any colder than that. Now, our next layer of the atmosphere is the stratosphere. No, this is not the stratosphere that hangs out down on the strip. This is the stratosphere that is within our atmosphere. Now, this goes up to about 50 kilometers above our Earth, and its lower layer down here towards this bottom edge is cold. It's about that negative 60 degrees Celsius. Now, however, the further up within the stratosphere that you get, it gets warmer, and that's because of the ozone layer. Now, if you don't know what the ozone is, ozone, O-Z-O-N-E, but the difference between this form of oxygen is that it has 3 atoms in each molecule instead of the usual 2. So when the ozone absorbs the energy from the sun, that energy is converted to heat, and it warms the air within that stratosphere layer. The ozone layer also protects the living things on Earth from those damaging ultraviolet radiation rays that come from the sun. Now, some of you may have heard, actually, that the ozone is a bad thing. Ozone within our air, actually down here on the troposphere where we live, it is a bad thing. It's a pollutant. However, when there's ozone up in the stratosphere, it's a good thing. It captures those bad rays that we don't want to come to the Earth that can actually harm us. Now, some scientists use the phrase good up high, bad nearby to describe those helpful effects of the ozone in the stratosphere and the harmful effects it can have here in the troposphere. Now, our third layer is the mesosphere, and this mesosphere extends to approximately 80 kilometers up from our Earth. And the difference between the stratosphere and the mesosphere is actually marked where the temperature changes, right about that area, to a negative 90 degrees Celsius. So it takes a big jump there. Now, this layer plays a very important role in our Earth because it actually protects us from being hit by meteoroids. Now, meteoroids, as we know, are just, stones and rocks and metal and those sorts of things that are coming from space. If you've ever looked up into the sky and you've seen a shooting star, that trail that is left behind by the shooting star is actually the meteoroid being burned up within the mesosphere. You may wonder how it could burn up if the temperature is that low 90 degrees Celsius. However, they're not actually burning up. It's actually a reaction from the friction with the gas molecules in the mesosphere that causes it to burn, as we say. And the last layer of the atmosphere is the thermosphere. Now, the thermosphere, though it looks as if it's pointing to just this spot right here, it's actually all of this, up. It begins at that 80 kilometers section, right? And it goes all the way out to the throughout our entire atmosphere. There is no stopping it. It goes on and on and on. Now, in the thermosphere, you would expect that you would see the temperatures continue to decrease, but that is not the case. This is actually where the temperatures increase. And amazingly, because of the sunlight striking the thermosphere, it can get very, very, very hot, and it can actually get up to 1800 degrees Celsius. And that is a positive, not the negative that you saw over here. It's a positive 1800 degrees Celsius. Now, within the thermosphere, there are two layers. The first is the ionosphere, and that actually comes up to about the 400 kilometer mark, so from about 80 on up. And that is, again, the IONO sphere. Okay, and then the other one is the exosphere, obviously EXO sphere. And that one is that 400 and up. Now, the cool thing about the ionosphere is that that is where the auroras that you can sometimes see up in the northern parts of the world, that is where they actually occur. When the sun strikes the atoms in the ionosphere near the poles, it creates those really pretty different dancing colors. This next section is about energy in Earth's atmospheres. Now, some sunlight is absorbed or reflected by the atmosphere before it can reach the surface of our Earth, and the rest passes through the atmosphere to the surface. Now, I don't want to talk about the different types of waves. We'll possibly deal with those when we hit chemistry and physics next year, but it actually has a couple of different sorts of energy rays that come through with the sunlight. So most of the energy from the sun, it travels to Earth in the form of visible light and infrared radiation. Now, a smaller amount arrives as ultraviolet radiation, which is what we talked about with the ozone layer and what it captures. Now, this last one here is the greenhouse effect, where gas holds heat in Earth's atmosphere. We'll talk about that in another slide or two. Okay, so when energy hits the Earth's surface, when the sunlight rays come down, come through those various layers of our atmosphere, then some of that sunlight or some of those rays kind of get some different things happening, right? They don't all get absorbed by our Earth. Some are reflected, some are absorbed, and some are radiated. So if we look at this picture and we use these words and we figure out what goes here. So let's look at this. So this first one here shows us that about 25% of incoming sunlight has something done to it by clouds, dust, and gases in the atmosphere. This one here is reflected. So it's reflected. It's bounced back up off of the clouds back out into the atmosphere. Now this next one here, this one right here, it states that about 20% is absorbed by gases and particles in the atmosphere. So it's just kind of taken up in those gases and those different particles, and they just kind of take that heat in. Now let's take a look at this one over here. This is a big one. About 50% is also absorbed by Earth's surface. This heats the land and the water. It heats everything. This is what you feel like when you're walking across the ground and you feel that heat coming up off of the sidewalk or off the dirt or the grass. That's being absorbed. That's where the sunlight has been absorbed by our land and or water. Now, some of this bottom one down here, some absorbed energy is radiated. You guys should remember that word back from when we talked about radiation and convection and convection. So then this last one down here, last one. So this one has about 5% is, let's say, reflected. So again, this is another reflected where it actually heads back into the atmosphere when it hits the surface of our Earth. The last section about the sunlight and the atmosphere is about the greenhouse effect. Now, the greenhouse effect is just like what you would expect it to be. What happens in a greenhouse? A greenhouse, it traps energy inside and allows plants to grow. Well, the same kind of thing is here, right? The greenhouse effect is a natural heat trapping process. This process actually holds heat in our atmosphere, and it actually is what allows our temperature to stay somewhere that is comfortable for most living things on our Earth to live in. Now, scientists have found evidence that states that we as humans on this earth, our activities are actually altering this process of the greenhouse gases. However, we'll talk about that when hopefully we get to it at the end of the atmosphere weather climate unit. This last section, I'd like you to take a look at this picture here, and these all happen in a specific order. This one is number 1. The sun's energy reaches Earth. Then it hits Earth's surface and is heated. Now the next thing it does is some of it is radiated off into space, but some of it is radiated heat that is absorbed by gases in the atmosphere, which is causing that greenhouse effect.